Hello, and thank you for watching this presentation. My name is Paul Doust, and I'm honored to have been invited by Drs. Oliver Burmeister, Anwar Ulhak, and Kirsten Wallström to present on our paper. My gratitude is amplified by the fact that I'm a complete stranger to the academic world, and I don't really know what I'm doing here. In fact, my only exposure to universities was when my girlfriend, who is now my wife, and I sneaked into an empty corner of her uni library so that we could be alone for a bit one cold winter night. And my sharing that story is probably a perfect example of what privacy doesn't look like. So let's move on to the topic. Today I will be digging into privacy, specifically the right to be forgotten, and how blockchain presents a significant challenge to this right. And then I'll talk about how Holochain, another peer-to-peer technology, takes a different approach that has the potential to resolve some of these challenges. I got acquainted with my co-authors when I discovered their original paper, Privacy by Design, a Holochain Exploration. I noticed that they left some questions open, and since I work on the Holochain project, I offered to explore the technical aspects of these questions with them. That conversation resulted in the new paper that I'm presenting on behalf of my co-authors today. Now, privacy is interesting because we intuitively know what it feels like, especially when it's been lost, but it's difficult to define it clearly enough to create practices that protect it. There are some useful definitions and descriptions in the literature. We kept these following points in mind. Privacy can be seen as the power to control or restrict access to information about us. Privacy is an instrumental social good. That is, its job is to support intrinsic social goods such as the right to security. Privacy comes from individual preferences and group norms that take different forms depending on the context. And privacy norms and preferences change over time. Privacy takes on a new importance in the digital age. James Moore talks about the information greasing effect of computers, and Luciano Floridi uses similar language when he says that a person's level of privacy is a function of the friction on their information as it flows through the infosphere. Now, interestingly, a lot of the information about us is not actually our own. It's generated by other people's appraisals of us. The government says that we exist. The credit bureau says that we used to have trouble paying our bills, but we're doing better now. The local pizza shop knows that we like mushrooms and anchovies. Now, privacy becomes super important in situations where one agent has an outsized level of power compared to another. We see this in the big search and advertising and commerce and social media platforms who can and do collect and retain and distribute and analyze massive amounts of information about us. Information that we create, information that others create about us, and information that these services themselves create. That's a lot of power. And the European Union recognized this and created the General Data Protection Regulation, which aimed to impose fiduciary responsibility on these organizations. In a sense, they are answering Floridi's call by using the power of the law to create some friction. One of the core pieces of this legislation is the right to be forgotten, to have information about us scrubbed from these organizations' computers. Blockchain, or distributed ledger technology, is quickly becoming a compelling alternative to centralized computing systems. One reason for that is that they take the big organization out of the picture and distribute power to multiple agents. But its integrity, its trustworthiness guarantee, rests on the fact that all of its data is immutable and permanent and publicly auditable. That is a serious challenge to the right to be forgotten, and that's something that Wallström and her colleagues identified in the previous paper. And it's difficult to figure out whether laws like the GDPR even apply here. They arose from the assumption that all data is held by an organization. But the very point of peer-to-peer tech, like blockchain, is that there is nobody in charge. There's nobody I can talk to when I want information about me scrubbed. There's no authority who bears the legal responsibility to do that. In fact, it would break the blockchain if anybody tried to. This is a good thing for public accountability, and it's a bad thing for privacy. Now, there is work being done to address these privacy concerns. That work is largely outside the scope of this talk, but there are some options. One of them is pseudonymous identity, which is something that Bitcoin actually pioneered. Another is using blockchain as a mere access control manager for data that lives elsewhere. And another is using advanced cryptography techniques to hide secrets in plain sight. Some of these are mentioned in the accompanying paper, and creators of purpose-built private blockchains can tune their designs to fit the context by drawing from all these options. However, for public blockchain platforms, users are limited by one-size-fits-all policies. These platforms don't yield graciously to contextual and changing needs. Now, Holochain, a developer toolkit for building peer-to-peer applications, aims to address some of these problems of privacy and agency by its very design. It starts from a very different ontological foundation, individual agency. This isn't an abstraction over top of a centralized structure like a cloud database or a blockchain ledger. This is the actual perspective from which all code runs. Each member of a Holochain application has their own copy of the application's executable code on their device and writes all data to their own source chain. This is a sort of a personal mini blockchain. And then on top of that is built the structure needed to interact with others. The core of any Holochain application is a piece of code called its DNA, which defines the rules of the game that bind together the group of people who use it. These rules, such as tweets must be 240 characters or less, or an account less than 60 days old can't carry a negative balance, define what the group needs in order to function coherently. This creates a natural tension between individual agency and the good of the group, and the creators of Holochain call this tension mutual sovereignty. Now, the group has a shared data space that records all the public activities of its members. This is called a distributed hash table, or a DHT. In the DHT, each member has a role in witnessing and auditing and storing a small portion of everyone else's shared data, which is what creates integrity without needing a global ledger. Now, while Holochain doesn't automatically lead to privacy by design, its agency-centric foundation strongly nudges developers towards privacy. This quality can also be seen in other systems that take the same agency-centric approach, such as Secure Scuttlebutt, which is a social network, DAT, which is a data sharing protocol, sort of like the web, and Git, which is a source code management tool used by most developers around the world. For Holochain, there are a few tools that developers can use to support users' right to privacy. First, not all data on an individual source chain needs to be published. Some data can stay on their device. This obviates the need to be forgotten by preventing private data from leaving the user's control in the first place. Second, access to an individual's private data can be automated with remote calls. These are just messages between agents' devices, and secured with access tokens with the option of constraining the use of these tokens to a select number of peers. Now, third, when I talk about public data on the DHT, I really just mean data that's visible only to other members of the same DHT. Each application has its own isolated encrypted network so that the information that's private to the group isn't accessible to others. The DNA's rules can also include membranes that allow or deny entry based on supplied credentials, such as invite codes or vouchers from existing members. An application's DNA can also be cloned so that separate groups can enjoy their own private spaces that operate with the same rules. Fourth, within a DHT, each member is only responsible for their own data and a portion of everyone else's, which Holochain calls a shard. This means that nobody has access to all data all the time, which does help apply some friction. Fifth, data can be marked as deleted, although this doesn't actually remove it from the DHT, it just marks it. However, access to the DHT data is mediated by the DNA. You'll remember that the DNA is the code that defines the rules of the game. A developer can craft the DNA's API to filter out deleted data from query results before it reaches the user interface. Highly technical users might still be able to access this data, but there's enough friction to prevent casual access. Now, sixth, the Holochain development team are planning direct support for the right to be forgotten with two special DHT operations, withdraw and purge, which will allow agents to ask their peers on the DHT to completely forget data. Seventh, beyond the base rules of individual ledgers and peer witnessing, Holochain doesn't impose any expectations on how an application should work. As a framework for creating normal applications that just happen to not have a server in the middle, Holochain could be interpreted as a superset of blockchain's functionality. This means that developers can tune their application to the context of the group that they're building for, and they can draw from a really broad toolbox of solutions. This sort of flexibility is difficult for one-size-fits-all public blockchain platforms to accommodate. And eighth, Holochain makes it inexpensive to upgrade the group's rules of the game, which allows an application to evolve along with changing social norms. Tools that we're planning include built-in migration routines and drop-in governance libraries to help a group decide on their own upgrade path. We still have open questions about how Holochain affects user privacy. Foremost is that the DNA developer has the ultimate power to create the rules for the groups that they're serving. They are the ones who decide how to use the features that I've mentioned: private data, access tokens, isolated networks, withdraw and purge, and all the others. So a developer with an immature appreciation of their group's context could create an inappropriate design that fails to give users adequate agency over how their data is used, or it might be inflexible and not be able to accommodate changing needs or individual preferences. One of the biggest design decisions is how to manage the tension between individual privacy and integrity of shared data. Private data is data that can't be audited, which means that it's harder for the group to ascertain whether somebody is a good or a bad actor. I can imagine situations where compromises might need to be made in one direction or the other. One example is the ever-popular use case for digital ledgers: finance. A currency application faces the choice of making everyone's transactions a matter of public record, which allows for full auditing and makes sure that nobody is forging credits that they don't have. But it also means that everybody can see who's transacted with whom and how much money everybody has. In some situations, high-trust situations, this could be perfectly acceptable, but in other situations it could be an absolute privacy nightmare. So the tension between privacy and integrity also shows up when considering how to use Holochain's ability to evolve. While a new set of rules might be better for a group, people will have already built a body of shared data that still exists under the old rules, and some of that data will still exist until the last member of the old DHT turns off the lights. Another issue is that the agency-centric nature of Holochain cuts both ways. Other people have as much agency as I do. That's especially important in the case of the withdraw and purge DHT features. Those are just polite requests for other peers to delete the data from their devices. So malicious actors might not feel like complying. We also have concerns about the lubricating power of connecting peers together with a computer network, and how this might be at odds with the way that people typically understand peer-to-peer interactions. Humans are accustomed to the friction embedded in real-life social situations, whereas peer-to-peer technologies turbo-grease data. In fact, the protocol that most of these technologies use, including Holochain and blockchain, is called a gossip protocol. So while it's true that agents in a peer-to-peer network are expected to participate by mutual consent, it's also likely that people will join these new networks before they completely understand how they work. So that brings me to what I consider the greatest need in the emerging field of peer-to-peer protocols as they begin to meet the real world. Developers, UX designers, advocates, and critics will need to understand and clearly communicate the impact that these new technologies have on user privacy. The non-guarantee of data deletion, for instance, suggests that users should exercise judgment about whether to share information in this or that context. Informed consent is always important where privacy is concerned, but it's doubly important when a new technology is introduced with new consequences. So I'm anticipating that users will need to make a big shift in their understanding of how an application is supposed to work as they move from using centralized applications to peer-to-peer applications. This shift feels similar to our transition from childhood to adulthood, from relying on our parents' protection to becoming adults who take responsibility for our interactions with each other. We also recognized in our paper that informed consent means different things to different people. A 12-year-old school child installing a holochain application can't be expected to understand these issues in the same way that a 45-year-old programmer can. Differences in age, culture, and technical proficiency indicate that we need to present different information and different choices to different audiences. So these are some of the challenges that we've identified. We invite you to present your own reflections, questions, and concerns in the forum, and we'll be available to explore them with you over the rest of the conference. We're really grateful to you for delving into this complex topic with us. Thank you very much.